Hello and welcome back to the Coder's Legacy channel. In today's video, I'll be explaining how the ExLlama cache works and how to effectively determine what size it should be. Now, I've already explained this before in my previous videos, what the cache is, what it's used for, but let's go through it again quickly for those of you who haven't. So I'm going to go over to the GitHub, and they have this nice diagram here that I thought we can use to understand how the cache works. Let's just start with this diagram, this one. This is the batching system that's used by ExLlama, where they take jobs. For example, the red colored bar is one job, the blue one is another job, the orange one is another job, and the green one is another job, and so on and so on. So these are jobs that are placed inside this cache, where they are then processed. So that's the purpose of the cache, to hold jobs and the output. So you see this over here, this slightly darker red, and then there's a lighter red in front of it. So that's the lighter red is the space that is reserved for the generation. So this is the input query, the prompt, okay, this one over here, this bar. This bar is the input, and this is the output space that's reserved for it. Same thing here. This darker blue is the input, and this is the output space that's reserved for it. The output space is like the max new tokens, like over here. Let me show you. The max new tokens that we give when generating our outputs when we're doing inference. Another important thing to keep in mind about the cache, another benefit of sorts, is that the cache reserves the space beforehand. For example, during inference, we need GPU memory. So let's say you're loading an 8 GB model, 8 GB LLM, and it takes up 8 GB of your memory, but that's not all. During inference, it's going to require additional memory in your GPU because of the weights and the tokens and all the calculations that are taking place on your GPU. So typically, for the average use case, it's going to take around 4 to 5 GB of extra memory. So the issue is that in other frameworks, what happens is that this is often the cause for a crash, because what happens in those frameworks, someone has, for example, 12 GB of GPU memory. He loads a 10 GB model. He only has 2 GB of space left. He does some short queries. He does some short prompts. Everything looks fine. He deploys his project. Then some user of his gives a big document or something. It uses more than 2 GB of VRAM, because he only had 2 GB left. So it uses more than 2 GB, and then it crashes. And then he's surprised because everything was fine in his testing when he was using smaller documents. So this is a common issue that can happen. ExLlama mitigates this issue by pre-allocating the cache. So let me show you my code. This is an example from the ExLlama repo, by the way. So you pre-allocate the cache by determining the number of tokens that will be stored inside it, such as 8,000. So this basically prevents nasty accidents from happening because it reserves the space beforehand. And if you don't have enough space for 8,000 tokens plus the GPU model, it's going to tell you right then and there during the initialization of your code. So you can adjust things accordingly. Okay, so that's basically the intro out of the way. Now we're on to the real purpose of this video, which is basically to find out how to define the size. How do we know whether this much space is enough for us? So to understand this, there's something I want to show you. This example. Let's take a look at this example. What this example does is that there's a story in this file, okay, a several thousand word story, and what we're asking, sorry, wrong file. What we're asking a bunch of questions to the LLM. These are all separate prompts because ExLlama supports batching. Right? So we're passing all of these questions at the same time to our LLM. Okay, we format the prompts. See, these are the questions. We format the prompts, give it a system prompt, and etc. And then we just pass them in here. So what's happening here is that the input text is also being appended. The input text being the text from here, which we read right? So we read that text and then we append it to the question while leaving some new line characters in between. So each of these prompts that are going in here, the length of each one of these is essentially the length of the story plus the length of the question being this, plus the length of the max new tokens, which is defined as 400. Okay, so this is the size of each prompt. Okay, let's calculate how much this is. So how much is the length of the story? Well, I've done this over here already, a print statement. So if I run this code, we'll find out what the length of the story is. It's basically what I do is do tokenizer.encode. I encode the input text, and that gives us our answer right there, 5641. That is the number of tokens in this story. See? Now we know that this is 5641. Okay, what is the length of the question? The length of the question is between 10 to 20 tokens. Let's just define it as 20 tokens. And what is the length of max new tokens? 400. So the size of each prompt basically is gonna be around 6,100 tokens. That's what the size is gonna be like. So how many questions do we have? We have 8 questions. So essentially what we have is, for the total size of the cache, it should be size of each prompt multiplied by the batch size, right? And where the batch size in this case is 8. So what this comes out to is, let's just calculate this. 6,100 multiplied by 8, which is 48,800. That's what the total size of the cache needs to be. But hold on, our cache is only 8,000 tokens. Now, if I run this code, it's going to work. So, how come? Right? How come when we're giving the LLM 48,800 tokens, how is it generating our output? Let's just wait for the output to come and then we'll continue. You can see here that our model, we're using the Llama 3 billion model, by the way, Llama 3.2, 3 billion, XL2 format Q5. So that's what we're using. It's taking up about 3 GB and the rest of it is being used by the cache. So you see here that it has responded to all of our questions. See? It's working perfectly fine. So how come? Let me explain this. This is the beauty of the cache in ExLlama. Normally, if the cache was a dumb cache, then we would need to define the cache to have about 48,800 tokens, but we don't need to. The reason being, ExLlama has this concept called deduplication, where we need to switch over to the graph now. So this diagram. So it has this concept called deduplication. Or honestly, there's a good diagram here too somewhere. Yeah, there's a good diagram that demonstrates this concept. It's basically prompt prefixing. So instead of, say, doing something like this, hold on, move this to the back. There. No, still not. Okay. So instead of us having to, we have essentially this example. What it shows you is that you have it's the same thing as the code, but in a simplified manner. We have 4 different questions, 4 prompts. We have the story appended with the question. So now in this, instead of being dumb and storing the story in here 4 different times, even though it's the exact same thing, what ExLlama allows you to do is to just store it like this. It'll essentially reuse this story for each of these questions. That's the beauty of the cache. Yeah, that's what's going on here. This is a slightly more complicated version of what I just drew. But if you read this carefully, and you can do that on your own time, it's essentially the same thing, where it uses prompt prefixing to ensure that you utilize the cache as effectively as possible. So yeah, that's the main thing that really goes into understanding how to calculate the cache size. Okay, just one short thing that I kind of want to go through. Ideally, when you're calculating your cache size, your formulas should look something like this. You should have a max input size that you know that your input will not be greater than this, and if it is, you might want to do some stuff like batching, like break that large text into smaller chunks, and you get those chunks processed separately. Okay, then you're going to have a max output size, also known as max new tokens, which for example might be 1000. All right, then you might have you can either include the prompt in here. Yeah, we'll just count this as the prompt, because sometimes you can treat the input and the prompt separately. But let's just pretend like this is both the input and the prompt. By input I mean like this is the prompt, for example, and the story was the input. So that's what I meant. Now, what your formula might look like, cache size is 4000. Oh wait, we need to have a batch size as well, a fixed batch size. So in which case this can be 8. And what else? So we can do now the thing is that it kind of depends on what you're doing. If you know, for example, that your prompts are always going to have the same prefix, then what you can do is something like this. You define the cache size as 4000, because that's the input. Then you can do max input size plus max output size, then what, multiplied by batch size. This is going to be your cache size in the case that you know that your prompts have common prefixes. But if they don't have common prefix, like the example I just showed you guys, but if they don't have common prefixes, if they have uncommon prefixes, so then you need to assume the worst case. Okay, you can only do this when you're 100% sure that you know that they're going to have common prefixes, because in the event that they don't have common prefixes, then that'll cause issues. It's not really going to crash your program. Okay, so for example, let's just go back here. So let's say that we actually had an additional story. Okay, and let's say that each of these stories are unique, and you gave 6 of these, or let's just go ahead and define 8. Okay, let's say that you had 8 of these, and each of them had a unique story, so each of them are stored separately over here, and you gave 8 of them at the same time. It's not going to crash. What it's going to do is first process these 4. Okay, it's going to complete these 4, and then it's going to move these 8 inside, and then it's going to process them. So it's not going to crash, it's just going to be slower. That's it. Okay, but obviously if you want the best performance, you need to define your cache size properly. But yeah, let's just get back to the example that we were doing. So if your cache prefix is uncommon, like even if there's like a 10% ratio, like most of them are going to be common but some of them are going to be uncommon, you still need to do this. So what you're going to do is, oh, and I totally forgot something. I'll get to that in a second. So you'll do something like this. Okay, but yeah, there's something I forgot to mention. Let's just remove that. I'll explain with respect to this one. So here's the thing. The cache size has to be a multiple of 256. It's kind of important to mention this because of the cache over here. The cache has a bunch of pages, each of which has these blocks, the individual blocks. They each have a size of 256 tokens. That is the smallest unit that can exist in a cache. So everything must be in multiples of 256. That is essential. And there's also going to be a little bit of wastage as well, because because if you have a 200 token input, for example, or let's say you have 1,000 token input, it's actually going to consume 1024 tokens in the cache. The reason being that this is a multiple, this is going to be stored in multiples of 256. So it's going to be stored like 256, 256, 256, and then it's going to be like 230, I think, or something. 234, I think, or 236. I don't know, 232, I think, because 24 minus 256, something like that. Yeah, so the 1,000 tokens is going to be stored something like this, but there's no such thing as 232 tokens. It's going to consume 256 tokens because that's a smaller unit inside the cache. So yeah, that's important to keep in mind as well, which kind of brings me to what I want to say. What I do in my code is that I divide this by 256. I take the floor of it, which gives me the multiple, okay, and then I plus by 1. It's kind of like this. Imagine this, because when you do this, 1,000 divided by 256, what do you get? You get 3, right? So you need to do a plus 1 into that to get the actual number of pages that you need. And once you get that, you can do multiply this by 256 again. And what I'm going to do is just comment all of this out for a second, and I'm going to run this. Just wait, sorry, I need to print this out. I want to see what our calculations resulted in. So according to our calculations, we're going to need 40,000 tokens, 192, and this is divisible by 256. Okay, but if we know that our input is going to be, prefixed, then what we can do is this, right? Move that out of there, and I've messed up the brackets here somewhere. I think there's an extra bracket. I hope I didn't screw this up. We should get a significantly lower value. Now we get 12,000. Okay, so 12,000 versus 40,000. That's the difference when you're dealing with this, So yeah, that's basically the end of my video. Hope you guys found this informative and useful. If you're interested in seeing more ExLlamaV2 content, do let me know in the comment section below.